Hi, my name is Ethan.
My name is Caitlin.
My name is Russell, and we are from King Kekalike High School.
For our NeuroMaker Design Challenge, we decided to focus on digit amputees. We used an engineering notebook to record our progress.
While conducting research on the variety of amputations performed on a hand, our team discovered that digit amputations were the most common type of amputation. It is performed to treat traumatic injuries to the fingers, such as biting, crushing, or shearing injuries.
Digit amputees face many challenges on a daily basis, such as performing simple tasks like picking up and holding a toothbrush. Our initial question for this project was, what could we build to improve or help digit amputees?
To visualize the patient's amputation, we modified the provided NeuroMaker hand to have one phalange on its pointer finger. The hand acted as our digit amputee. The separated digit was then used as a prosthetic for our prototype.
Our original plan was to make a glove to go over the patient's hand. The glove would have the prosthetic digits placed in it with a makeshift tendon piece to allow the user to use a functioning hand. After conducting more research, we decided to turn the glove into a band. We used inspiration from existing prosthetics to design the band.
When designing our first prototype, the band was too small. There was also a part of the band that restricted the thumb from moving properly. When designing our second prototype, the band was altered to allow the thumb movement and connect the prosthetic finger to a band via a ring piece.
In reality, this band could be personalized to the hand of the amputee. It would also be made of a more flexible material and have added cushions for a comfortable fit. When tension is transmitted through the string, it causes the connecting digit prosthetic to move into a curved shape. This allowed the prosthetic to bend when the finger and hand moved.
Although the finger had adequate movement, our limited time and materials made our prosthetic ineffective at picking up objects.
If given more time, we would add the previously mentioned cushions, adjust the tension of the tendon, and model our prototype using other materials to find the most comfortable fit for the patient. And this is our final prototype.
Thank you for watching our presentation, and we hope you have a great day.